Hello learners, here we have an equation which represents a pair of parallel lines, and if that is the case, then we need to show that h square is equal to ab, af square is equal to bg square, and that distance between the two parallel lines which this equation would represent is equal to this. Okay, it could be either one of them, so we need to show our proof in a similar fashion. Okay, now let's see the standard way. The first step would be that, okay, this is what we need to prove. I just kept it at the top of the screen so that at any point of time you can just refer to it. Now let ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 represent lx plus my plus n1 is equal to 0 and lx plus my plus n2 is equal to 0. Now, why it came out like this is why not L1x plus M1y plus N1 and L2x? Because here it's given that this equation represents a pair of parallel lines. Parallel lines only differ in their constant. So that's why if my first equation is Lx plus My plus N equal to 0, then my second equation is going to be Lx plus My plus N2 equal to 0. The first two terms remain as it is. Okay, this is the first part which all of you need to understand. Okay, next. Now, now since this represents this equation, so I can like make sure that ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0 is nothing but lambda times lx plus my plus n1 into lx plus my plus n2. Okay, now why did this lambda come is sometimes this won't match. Okay, exactly, some factor could be there between which will make sure that two equations will turn out to be equal. So that's why this lambda is important. Okay, now next. Yes, now I'm going to multiply the RHS. Okay, I'm going to show things in a step-by-step manner. So stay with me. If you feel like I'm going a bit slow, you can just increase the speed. Okay, to 1.25x or 1.5x. It's totally fine. Plus by square plus 2gx plus 2fy plus c is nothing but lambda times. Now this first term into second bracket. Okay, this would be nothing but lx into Lx plus My plus N2 plus this second term into second bracket plus My into Lx plus My plus N2 and then plus this third term N1 into the second bracket plus N1 into Lx plus My plus N2. Okay. Now, LHS is like fixed, so you can just keep it as it is and get on with working with RHS. Now here, Lx into Lx is L square x square. Okay, L square x square plus Lx into My is Lmxy. Okay, I'm just rearranging it. The constants I'm putting it forward, and then the variable at the end, and then plus Lx into N2. So I'm making it as L into x. Okay, L into x plus My into Lx. It would be nothing but Lmxy. Lmxy plus My into My. M square y square. M square y square plus My into N2. So it's going to be M N2 y. Now next, plus n1 into Lx, it's going to be ln1x. I'm writing my constants of the order lmn, okay, so that it will be easy whenever there is an order like this in handling it. So this should be nothing but ln1x plus n1 into my. It's going to be mn1y. mn1y plus n1 into n2. n1 into n2. Okay. Now this is nothing but equal to lambda into, let's try to group terms. Okay. Let's try to group terms. Now L square x square, keep it as it is. See how I'm going to group it is such that I'll get something of similar order. So in the LHS, the first is ax square. Okay, so basically x square term is in the beginning. So here also I have x square term in the beginning. Here it's L square x square. L square x square plus. Now I want xy term. Here what are the xy terms? lmxy plus lmxy. lmxy plus lmxy is going to be 2 lmxy. Okay, 2 lmxy plus 2lm xy plus. Now next I want by square, sorry, y square term. Y square term is here, m square y square plus m square y square. Next I want x term. Now x term, what all I have, ln2x, that is one thing, and also have ln1x. Okay, ln2x and ln1x. So I can take out lx common, and then I'd be left out with n1 plus n2. Okay, in these two terms, ln2x and ln1x, if I take lx common, I'd be left out with n1 plus n2. So plus l into n1 plus n2 times x plus. Next I want y term. Okay, next I want y term. So y term, where all I have in this mn2y and then mn1y. So again, if I take my common, I'd be left out with n1 plus n2. So m into n1 plus n2 times y. And then at last I want a constant. Okay, what else is left out? n1, n2. That's my constant. n1, n2. Now this is nothing but equal to. This is nothing but equal to. I'm just multiplying lambda everywhere. Okay, to each and every term. So I'd get lambda L square x square plus 2 lambda lm xy plus lambda m square y square plus lambda L into n1 plus n2x plus lambda m into n1 plus n2y plus lambda n1 n2. Okay, now this, all these terms on the RHS are actually equal to the terms of the LHS. Now actually you can write by comparing LHS and RHS. So basically what you have on the LHS, you have okay, I'll just put it down here at least a bit small, in a small way. Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c. These two are equal. What I just wrote the LHS again. Okay, here. Now here, what is the coefficient of x square on the left hand side? It's a. What is the coefficient of x square on the right hand side? Lambda L square. Whatever is there beside x square, you need to treat it as its coefficient. Okay, so it's like lambda L square. So here, so you can write here. This is an important step. Stay alert. Here a is lambda L square. Here a is lambda L square. Okay. Now similarly, okay, now mark it as 1. Okay, now mark it as 1. Like this, you will get 6 things. Okay, you need to mark them all in a similar order. Now let us compare the coefficient of xy. The coefficient of xy on the LHS is 2h, whereas on the RHS it is 2 lambda lm. Okay, 2 lambda lm. So 2h is equal to 2 lambda lm. This is my equation 2. Okay, fine. Now Here on the LHS, my coefficient of y square is b. On the RHS, it is lambda m square. B is equal to lambda m square. So this is my equation 3. Next, coefficient of x is 2g on the LHS, and coefficient of x here is lambda L into n1 plus n2. 2g is nothing but lambda L into n1 plus n2. Lambda L into n1 plus n2. This is my fourth equation. Now, 2f is nothing but lambda m into n1 plus n2. 2f is nothing but lambda m into n1 plus n2. This is very important step, guys. So you need to be focused here. So now again, my constant c is nothing but lambda n1 n2. C is nothing but lambda n1 n2. Okay, this is my equation 6. Okay, now I got all the 6 equations. Okay, now I got all the 6 equations. Now I'm going to just simplify whatever it's possible. Like for example, 2h is nothing but 2 lambda lm. So 2 if I'll I'll cancel. This implies that h is equal to lambda l m. Okay, h is nothing but lambda l m. Now I'm going to use this. Okay, from 2. What is the first thing that I need to prove? I need to prove that h square is equal to ab. Okay, so first I need h. Okay, and then I'll square it, so that, and then I'll try to prove that the RHS is equal to ab. Now how I'm going to do it is, stay with me. From 2, h is equal to lambda lm. Okay, this implies that now I'm squaring on both sides. I'd get h square is equal to lambda square L square m square. Okay, h square is nothing but lambda square L square m square. Now observe how I'm going to split it. See, lambda square, I can write it as lambda into lambda. Okay, so why I'm doing is, you'll understand. This is nothing but, this implies that h square is lambda L square into lambda m square. I hope you're clear up to this. Now, what is lambda L square? If you'll observe the first equation, What is lambda L square? It's A. Now, what is lambda m square? If you'll observe the third equation, it's P. That's it, done. This implies that h square is equal to AB. How did we prove it? From 1 and 3. It's always important to give your reference. Okay, like how did this turn out to be this? So that's why. So now we are done with sort of 1/3 of our question. Okay, we are done with sort of 1/3 of our question. Now, next what I have is AF square is equal to BG square. AF square is equal to BG square. How I'm going to do it is, now see, now let us divide first 1 and 3. Okay, 1 by 3 implies 1 by 3 implies means basically I'm dividing equation 1 and equation 3. This implies that LHS, I'd get A by B is equal to lambda L square by lambda m square. A by B is equal to lambda L square by lambda m square. I'm not done anything much. I've just divided both the equations. Like LHS of the equations would get divided and RHS of the equations also would get divided. Fine. Now, this implies that A by B is equal to L square by m square. A by B is nothing but L square by m square. Okay. Okay, now A by B is nothing but L square by m square. Okay. Now what I'm going to do is I'm going to divide 4 and 5 so that I'll get G by F. Okay. I'll get G by F. Now divide 4 by 5 will imply, I'll just squeeze it here only because it will be easier to see. 4 by 5 implies 4 by 5. What is LHS of 4? 2G by 2F. 2G by 2F is nothing but equal to lambda L into n1 plus n2 divided by lambda m into n1 plus n2. Now if you'll observe carefully, 2 will get cancelled and n1 plus n2 and lambda will get cancelled. This basically implies that G by F is equal to L by M. G by F is L by M. Now mark this as 7. Okay. Now, okay. Fine. Let me just say mark this one as 7, equation 7, and this one as equation 8. Now, basically L by M is G by F. So put 8 in 7. Okay. Put 8 in 7. Put 8 in 7. Put 8 in 7. If you will put 8 in 7, in place of L by M, I'm going to put G by F. So here it is L by M whole square. So A by B is nothing but G by F whole square. Okay, A by B is nothing but G by F whole square. Okay, so A by B is equal to G square by F square. Now just do cross multiplication. This implies that AF square is equal to BG square. Okay, this was our second thing which we had to prove. Okay, I know it's going lengthy, but still, you will have to have patience, and when you do it on your own, it will seem fun. Okay, while I'm explaining, you might feel it's going a bit lengthy, but once you start doing it, you yourself will understand. Now, next. Now here on, now till here, I would say 50% of the question is done. Now rest 50% comes into picture from here. Now basically we need to show that the distance between the two parallel lines. Okay. In case if you're not aware, I'll just give you the formula for distance between parallel lines. Let's say if my parallel lines are ax plus by plus c1 equal to 0 and ax plus by plus c2 is equal to 0, then the distance between the parallel lines is nothing but mod c2 minus c1 divided by under root of, okay, mod is only for the numerator, under root of a square plus b square. Okay, mod c2 minus c1 divided by under root of a square plus b square. Now similarly, here our parallel lines are lx plus my plus n1 and lx plus my plus n2. So my distance is going to be mod n2 minus n1 divided by under root of l square plus m square. Fine. Now distance between the parallel lines is equal to distance between parallel lines. Distance between parallel lines is equal to mod n2 minus n1 divided by under root of L square plus M square. Okay. Now again, here you will have to give some good attention to me because another critical step is coming up. Now what is this mod under mod of n2 minus n1? How can we just write it? That's what I'm going to explain it to you. Fine. Now from here, what I'm going to explain it, you do not have to write it in exam, but I'm going to give it for your own understanding. Okay, but I'm going to give it for your own understanding. So n1 plus n2 whole square plus n2 minus n1 whole square is nothing but, it's not, okay, fine, I need to do minus actually. I need to do minus. Minus this is equal to 4n1 n2. 4n1 n2. This is very basic. Okay, a plus b whole square minus of a minus b whole square formula. If you'll apply this much, you would get this one. Fine. So then now what I want is modulus of n2 minus n1. Okay, so what I'm going to do is I'm going to take n2 minus n1 square to the RHS and then 4n1 n2 to the LHS. Okay, so I'd get n1 plus n2 whole square minus 4n1 n2 is equal to n2 minus n1 whole square. Now what I'm going to do is I'm going to apply under root on both sides. So if I'll apply under root, what I'd get is under root of n1 plus n2 whole square minus 4n1 n2 is nothing but equal to under root of n2 minus n1 whole square. See, a root of a square is nothing but modulus of a. Root of a square is nothing but modulus of a. So here I'd get modulus of n2 minus n1. So you see, in place of mod n2 minus n1, I'm going to put this. Now you guys might think, why did I do this entire thing? Okay, why am I doing this? Because I don't know what is n2 modulus of n2 minus n1, but I know what is n1 plus n2. Okay, what is n1 plus n2? It is nothing but 2g by lambda l or 2f by lambda m. So I have two options, and I also know what is n1 n2. N1 n2 is nothing but c by lambda. N1 n2 is nothing but c by lambda. Fine. So this is nothing but equal to under root of n1 plus n2 whole square minus 4 n1 n2. Stay with me, guys. We are almost coming to the end. Divided by under root of L square plus m square. Okay. Now this is a critical step. Understand. In place of n1 plus n2, in place of n1 plus n2, I can write n1 plus n2 as 2g by lambda L. Okay, from equation 4. N1 plus n2 is nothing but 2g by lambda L. And from equation 5, n1 plus n2 is nothing but 2f by lambda M. So I can take it anything. Okay, that's where two options come. Okay, that's where two options come into picture for n1 plus n2. Okay, that's where two options come into picture. So I can write it here. You can just break it like this. N1 plus n2 is nothing but equal to 2g by lambda L. 2g by lambda L. This is nothing but equal to 2f by lambda M. 2f by lambda M. From this, how I'm getting is, I'm getting it from 4 and 5. Okay, I'm getting it from 4 and 5. I'm getting it from 4 and 5. Okay, now again just put it, distance is nothing but equal to, distance is nothing but equal to under root of n1 plus under root of, in place of n1 plus n2 I can put it as 2g by lambda L, 2g by lambda L whole square minus 4. What is n1 n2? N1 n2 is c by lambda. From 6 you can get n1 m2 is c by lambda, divided by under root of L square plus m square. See, if you'll observe in my answer, there is no LM. Okay, there is only AB. Now, basically, I need to replace LM by with AB. Now, how I'm going to do it is, see, from equation 1, I can write L square as A by lambda. From equation 1, I can write L square as A by lambda. And from equation 2, I can write M square as B by lambda. So, all this you need to mention it. Okay, this would be nothing but it was L square plus M square. So, this would be nothing but A by lambda plus B by lambda. Okay, or distance is nothing but this is equal to under root. What was my other case for n1 plus n2? It is 2f by lambda. It's 2f by lambda. So this would be nothing but 2f by lambda m whole square minus 4 times c by lambda divided by same a by lambda plus b by lambda. Fine. Now okay, now you need to give reference to what all you used from. What was the first thing we used? We used like n1 n2, so that is from 6, and what else we had used? And 1 and 3, 6, 1 and 3, from 6 comma 1 and 3. Okay, this is what I have with me now. Now stay with me. How I'm going to simplify. It's easy from here. It's not that difficult. So this would be nothing but 4g square by lambda square L square minus 4c by lambda divided by what do I have is under root of a plus b by lambda, under root of a plus b by lambda. Okay, or this would also be equal to under root of 4f square by lambda square m square minus 4 times c by lambda divided by under root of a plus b by lambda, under root of a plus b by lambda. Now next, now let's go. Now here I'm going to take LCM. Okay, now here I'm going to take LCM. what I'd be left out with is 4 if I'll take it 4g square minus 4 lambda L square. Okay, under root of 4g square minus 4 lambda L square c. Okay, divided by lambda square L square, that's my LCM, divided by lambda square L square divided by under root of a plus b by lambda, or this is nothing but equal to under root 4f square minus 4 minus 4 lambda m square c. Okay, lambda m square c divided by lambda square m square divided by under root of a plus b by lambda. Now, what would this be equal to means? See, lambda L square is what it's A. If you'll remember the first equation, lambda L square is A. And here I can take 4 common. So what I'd be left out with is, and here if you'll observe, 1 lambda and 1 lambda would get cancelled because everything is in like sort of like in the under root. I'll consider it as like one term. So this would be nothing but under root 2 into g square minus AC. Okay, because lambda L square is A minus 4g square minus 4AC. 4 I'm going to take 4. Okay, it's 4. Sorry, I'm sorry. 4 times this divided by under root of here 1 lambda got cancelled. Lambda L square into A plus B. Lambda L square into A plus B. Or this is also equal to under root 4 times f square minus lambda m square is b. Okay, lambda m square is b, f square minus bc divided by under root lambda m square into a plus b. So now this, for this what I used is from 1 and 3, from 1 comma 3. Now this is nothing but my last step. Root 4 is nothing but 2, so this would be nothing but under 2 root g square minus ac divided by root of a into a plus b, because lambda L square is a, or this would be nothing but 2 root f square minus bc divided by under root b into a plus b into a plus b. Okay, again from 1 and from 1 comma 3, from 1 comma 3. That's it. Thank you. So in case you like, this is what we had to prove, the distance, right? You can just see it. So thank you. In case you like this video solution, please hit the like button, and if this is your first time coming across my channel, please do subscribe to it.